Hello everyone, welcome to another video. Now in this segment we'll be looking at how to solve this thermal physics problem. Okay, now the question reads a 200 gram block of copper at a temperature of 90 degrees Celsius is dropped into 400 grams of water at 27 degrees Celsius. The water is contained in a 300 gram glass, okay, container. What is the final temperature of the mixture? All right, so to be able to find the final temperature of the mixture, now it is important for us to write the values we are giving. Let's write down the values that we are giving from the question. So we have so the first we have here that the mass of copper, okay, is equal to, the mass of copper is 200 grams. Okay, then we're also giving the first temperature of copper because the copper was heated to 90 degrees Celsius before it is dropped into the glass container containing water. Okay, so which means the first temperature of copper, so temperature of copper is equals to 90 degrees Celsius. Now we are not giving the specific heat capacity. In my previous video I talked about questions like this when we are not giving the values for specific heat capacity, so which means students are expected to know these values. So for copper, remember, now I use the specific heat capacity of copper. Okay, specific heat capacity of copper is 0.385, okay, joules per gram per degree Celsius. So that's for, these are the informations for the copper, okay, in this case. Now 400 grams of water. So for water we have mass of water is 400 grams. Then we're not giving the specific heat capacity. Now the water, when the copper, before the copper block is dropped into the glass container containing water, the temperature of water is what? Is already at 27 degrees Celsius, meaning the initial temperature of water is 27 degrees Celsius. Okay, so which means we're going to have the initial temperature, which is the first temperature, the initial temperature of water, okay, plus glass container, plus the glass container is 27 degrees Celsius. So this is important. Now we're not giving the specific heat capacity of glass container, but we know that the specific capacity of water, okay, the specific heat capacity of water is 4.18 joules per gram per degree Celsius. Now also we are given the mass of container, okay, mass of glass container. So the mass of glass container is given to be 300 grams. The mass of glass container is given to be 300 grams. Now the specific heat capacity of glass container is not given, okay, but the value is 0.84 grams, no, joules, okay, 0.84 joules per gram per degree Celsius. That is the specific heat capacity of the glass container. So now remember I said the initial temperature of water plus glass container is 27 degrees Celsius. Now to be able to calculate the final temperature of the mixture, when the copper block is dropped into the glass container containing water and the mixture is stirred thoroughly in order to aid equilibrium temperature. Now a thermometer will be introduced. So this thermometer is going to read and record the final temperature of the mixture. So the final temperature of the mixture, we can say let TF, okay, this represents what? Final temperature. This represents final temperature of mixture. Okay, final temperature of mixture. So that's it. Okay, final temperature of mixture. So now we are going to set up the equation. Okay, we're going to set up the equation for heat lost by copper block equals to heat gained by water and the glass container, using the principle of what? Conservation of energy. So let's set up the equation. So we know that by principles of conservation, okay, conservation of energy, okay, we know that heat lost equals to heat gained. Heat lost equals to heat gained. So we have heat lost by copper block, heat lost by copper block, which is Q lost, okay, will be mass of copper multiplied by the specific capacity of copper. Now the temperature difference will be the 90 degrees Celsius, which is the first temperature of copper, and that will be temperature of copper minus the what? Minus the final temperature. When the copper is introduced or dropped into the glass container containing water, and the mixture is stirred thoroughly to aid even or equilibrium temperature. Now, a thermometer, when the thermometer is introduced to read and record the temperature of the mixture, okay, that now becomes the what? Now, the temperature decreases from 90 degrees Celsius to that temperature, which is the final temperature of the mixture. So we have the final temperature to be what? To be TF. Okay. Now, let's plug in the value. So we have the heat lost to be mass of copper is 200. Then multiply by specific capacity of copper, which is what? 0.385 multiplied by 90 minus TF. Okay, so let's multiply 200 by 0.385. That will be 77. So this will be Q lost will be equals to 77 multiplied by 90 minus what? TF. So this is the equation for, this is the what? Equation for, that's the expression, that's the equation for heat lost by copper block. Now, heat gained. Now, heat gained, that's, we have heat gained by water and the glass container. So that means that will be mass of water multiplied by specific capacity of water plus mass of the glass container multiplied by what? Specific capacity of the glass container. Then multiply by, the temperature difference will be the same for water and the glass container. So that will be, the temperature difference will be the final temperature minus 27 degrees Celsius, which is the what? The initial temperature of the glass container and water. All right, so this is it. So let's plug in the values. So Q gained, which is heat gain, mass of water is given to be 400. So we are multiplying it by the specific capacity, which is 4.18. Okay, so 400 times 4.18 plus mass of glass container, that is 300. Then multiply by the specific capacity of the glass container, which is what? 0.84. That's 0.84. Then that will be multiplied by TF minus 27. Okay, so what is 400 multiplied by 400 multiplied by 4.18? That will be 1672. So the heat gained will be equals to 1672 plus 300 multiplied by 0.84. 0.84. That will be 252. 252. Then we have TF minus 27. Okay. So 252 when added to 1672. That will be 1924. All right. So this will be 1924 multiplied by TF minus 27. So this is the what? This is the equation for the heat gained by water and the glass container. So we are now going to set, we are going to what? We are going to set the heat lost, this, we are going to set this equal to the heat gain. This is the heat gained. Okay. We are going to what? Equate. All right. So in this case, we are going to have heat lost equals to heat gained. Okay, so heat lost is 77 multiplied by 90 minus Tf, which is the final temperature of the mixture. Okay, 1924 multiplied by the difference between the final temperature of the mixture and the first or the initial temperature of water and the glass container. All right, so we're going to remove the parentheses on both sides, okay, using distributive property, okay, and then we can combine the like terms. So we have 77 multiplied by 90, okay, that will be 6930. So we have 6930, then this will be 77 negative 77 TF, 1924, okay, multiplied by 27, that will be 51948. So 1924 times TF, that will be 1924 multiplied by TF, then minus 51948. Okay, so now we can combine like terms. So we combine like terms, okay, so that this is going to be added together. 6930, 51948, 1924 final temperature plus 77 then TF. So 6930, okay, when added to 51948, that would be 588, that will be 588, okay, 78 equals to 1924, okay, plus 77, that will be 2001 multiplied by TF. So to be able to get the value of TF, so we're going to divide both sides. That is, divide both sides by what? 2001. So we have 58878 divided by 2001 equals to 2001 then TF over 2001. So that TF will be equals to 58878, okay, 58878 divided by 2001, and that will be 29, okay, 29.42 degree Celsius. And this is the final temperature of the mixture. This is the final temperature of the mixture, which is the same as the equilibrium temperature, okay. So, and that's it. The noblest pleasure is the joy of understanding. Bye bye.